Okay, this is the last section of the review, just solving equations. Starting with these first few rational equations. If you remember that what you want to do first is factor everything. So looking at the left side, I can factor that 2x minus 2x minus 4 equals 3x. I'll write all the rest of it down. And I'm going to leave a little bit of room there. That'll give me some room to do some work. And first thing I'm going to do is multiply everything by the common denominator, which for this problem is x minus 2, x minus 4. Multiply by x minus 2, x minus 4. Multiply this one by x minus 2, x minus 4. And the idea behind that is you will cancel all of the denominators. X minus 2 cancels, x minus 4, leaving you with only a 4 on the left side. X minus 2 cancels, leaving you with 3x and x minus 4, plus x minus 4 cancels, leaving you with 2 and x minus 2. And now we've gotten rid of all the fractions, and we're down to solving the equation with algebra. Distribute. I already have a positive x squared, so I'm going to leave everything on the left side. I will move this 4 over. Minus 4 minus 4. And that will give me 0 equals 3x squared. Negative 12 plus 2 is negative 10x minus 4. And that will factor to, let's see. My first two have to multiply to give you 3x. My last two have to multiply to give me 4. Is that right? Something's not right here. Hang on a sec. Yeah, negative 4 minus 4 would be negative 8. There we go. Now I need factors that multiply to give me 8, so I'm thinking 2 and 4. Let's try this. And minus 4 and plus 2 will work. Be negative 12x, 2x. Yeah, so you can multiply that out to check it. And then you set each factor equal to 0, and you get x equals negative 2/3, and x equals 4. So there's our answer for number 14. Number 15, same thing. We're going to multiply everything by the common denominator. No factoring needed on this one, so I'll just rewrite it. Give me room to multiply by the common denominator. And my common denominator in this case, this is over 1. My common denominator is simply x minus 8. I'm going to multiply everything by x minus 8. X times x minus 8 is x squared minus 8x. Those cancel, leaving you with just a plus 6 equals 0. Then you need factors of 6 to add up to 8. I don't think there are any, which means you'll have to use quadratic formulas. So negative b plus or minus the square root of b squared. Negative a squared is 64. Minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which would be just 2. All right, so I did some cleaning up there, and you have the square root of 40. The square root of 40 is 4 times 10, and the square root of 4 is 2, so that cleans up to 8 plus or minus 2, square root of 10, all divided by 2. And you can reduce this, even though you are adding up here, as long as you remember to take a 2 out of everything. 2 goes into 8 4 times, and 2 goes into 2 once, and we don't have to worry about the radicals. So our final answer is just 4 plus or minus 1 times the square root of 10. Kind of ugly, but there you go. Always have to remember that quadratic formula. Let's see, moving on. How far along are we? 4 minutes. Okay, this one, ooh, notice this is an inequality. So this is one of those where we're going to have to answer with interval notation. You always want it to equal 0. We will factor that. Factors of 32 to add up to 12 would be 4 and 8. And this is the one where you will find out first what makes this equal 0. So that's going to be 4 and 8. And you put those numbers on a number line. And you will plug in test points. My test points are something to the left of 4 would be what? Like 0. Something between 4 and 8 would be 5. Something after 8 would be 9. And I like to put zeros above my 4 and 8 because those are actual zeros of the equation. They're roots, x-intercepts. And if I plug in 0, I like to plug into the factored form. 0 minus 4 is negative. 0 minus 8 is negative. Multiply two negatives, you get a positive. Plug in 5. 5 minus 4 is 1, which is positive. 5 minus 8 is negative. Plug in 9. 9 minus 4 is positive. 9 minus 8 is also positive. Multiply two positives. So I do my number line, and then we look at the inequality. I want things that are greater than or equal to 0, and numbers that are greater than or equal to 0 are positive numbers. And I want to include 0. So my positive numbers and 0 are going to be this, and I'll include the 0, which means I'll include 4, and I will include 8 over here. So my answer is everything before 4 with a bracket, because we will include the zeros, and then everything after 8 with a bracket onto infinity. See, number 17, same thing, another inequality. This time we're going to have to factor this. So my top factors to x plus 3, x minus 3. My bottom factors to x plus 4, x minus 3. Less than 0. I can cancel an x minus 3, but when you cancel, you need to be aware that you just created a hole. Because I canceled an x minus 3, I have a hole at x equals 3. And I'm reducing my equation down to x plus 3, x plus 4, over x plus 4, less than 0. And then we look at my top and bottom. My top is 0 at negative 3, and that's a root. If my bottom is 0, it didn't cancel. If my bottom is 0, then that's a vertical asymptote. So my number line, I have 3 things to put on my number line. I need to put my x-intercept, my vertical asymptote, and my hole. Make sure you put them in order. Vertical asymptote is negative 4. That's my smallest one. And then negative 3. Now it's an x-intercept, so I'm going to put a 0 there. And I have a hole at positive 3. And I'll just label that as a hole. Then we pick our test points. And I like to plug my test points into the reduced form. That's perfectly fine. Plug it into x plus 3 over x plus 4. If I plug in negative 5 plus 3, that'd be negative. Negative 5 plus 4 is negative. And 2 negatives give you a positive. If I plug in negative 3.5. Now that's a little bit tricky one because negative 3, negative 4, I have to pick a decimal. Negative 3.5 plus 3 is negative. Negative 3.5 plus 4 will give you a positive number. So that's negative. If I plug in 0, 0 plus 3 is positive. 0 plus 4 is positive. 2 positives give you a positive. If I plug in 4, 4 plus 3 is positive. And 4 plus 4 is also positive. So that is a positive. And then I look at my inequality, and we have to decide what kind of answers I'm looking for. Things that are less than 0, not including 0, I need negative numbers. So my negative numbers are right here. I'm not going to include any zeros. And that interval is everything between negative 4 and negative 3. So negative 4, negative 3, not including. And that would be your answer. Pretty good? Pretty good? Pretty good? Moving on. Okay, number 18. I'm going to change this problem because I worked it out once and it really blew up on me. So what we're going to do is we're going to change this problem. Instead of 5 over x minus 3, instead of that thing, I'm going to change it to number 18 being 5 over x plus 2 is greater than 3 over x minus 4. That's going to make this problem a little bit nicer, just because the original number 18 really made it tough to pick your numbers for your number lines. So we're going to change it to that. And when you have an equation like this, where your fractions are separated, you want everything over to one side, and you want to make this thing equal 0. So I'm going to start by taking this 3 over x minus 4, and we're just going to grab that and move it to the other side of the equation, giving us this. So we have this, and then you need to get a common denominator and combine these into one fraction. So my common denominator is going to be x plus 2, x minus 4. So I've got to multiply this side by x minus 4 over x minus 4. Same thing over here, except I'm missing the x plus 2, so I'm going to multiply by x plus 2 over x plus 2. That will give me 5 times x minus 4. And then that's a negative 3, so I'm going to say minus 3 times x plus 2 all over my common denominator of x minus 4x plus 2. That needs to be greater than 0. And then we need to distribute and clean up my numerator. There we go. And when you clean it up, you end up with this equation, which I'm kind of running out of room, so I'm now going to pull that up and just copy it to the top of the page right here. And then we will continue solving the equation. Well, that was terrible. Let's try this again. There. So now we're going to finish solving this, and we need to find x-intercepts and vertical asymptotes and holes. My x-intercept, my top, if I set my top equal to 0, 2x minus 26, set that equal to 0, you add 26, divide by 2, and you get 13. That's an x-intercept, also known as a root. And then I have vertical asymptotes at whatever makes my denominator 0. That's going to be x equals 4 and x equals negative 2. And those are the numbers I need to put on my number line. So let me draw my number line here. There we go. And pick your test points. Something to the left of negative 2, something between negative 2 and 4, something between 4 and 13, and something after 13. And make sure you make note above your initial numbers what's happening. We have 2 vertical asymptotes at negative 2 and 4 and the 0 or the x-intercept at 13. So we plug in. And I like to plug into my factored form, so I'm going to plug in right here. 2 times negative 3 minus 26 is a negative number. Negative 3 minus 4 is negative. Negative 3 plus 2 is negative. And 3 negatives do give you a negative. If I plug in 0, 0 minus 26 is negative. 0 minus 4 is negative. 0 plus 2 is positive. 2 negatives and a positive give you a positive. Plug in 5. 2 times 5 minus 26 is negative. 5 minus 4 is positive. 5 plus 2 is positive. And that's going to give me a negative. And then plug in 14. 2 times 14 is 28. Minus 26 is positive 2. 14 minus 4 is positive. And 14 plus 2 is positive. So that's all positives. And then we have to look back at my original problem, or what I'm solving here. And I need numbers bigger than 0. That's going to be positive numbers. But not 0. So I will do everything from negative 2 to 4, and then everything after 13. So my answer is all numbers between negative 2 and 4, and all numbers after 13. We won't include anything because I'm not equal to 0. And so there's our answer. Let's see, number 19. Solving this thing, let's see. It's a cube root. I want to blow this up so I can read it a little bit better. Before I start tackling the radical, you want to get the radical by itself. So let's move that 5 over, and that gives me the cube root of x plus 17 is equal to negative 2 plus 3 plus 5 is 3. Now we will cube both sides. That gives me x plus 17 equals 27. 3 cubed is 27. Subtract 17 and you get 10. That wasn't too bad, was it? Nope. Yeah. And then number 20. This one is a pain because we have 2 radicals, which means it's going to take a little bit of time. We're going to have to square both sides. The right side's going to be easy because if I square that, I'm just going to get x plus 2. The left side is a pain in the butt because you have to square that in its entirety. You can't just square the parts individually, which means we have to FOIL this out. It's root x plus 7 minus 1 times root x plus 7 minus 1, and we have to FOIL that. Root x plus 7 times root x plus 7 would be just x plus 7. Root x plus 7 times negative 1 is minus root x plus 7. Negative 1 times root x plus 7. And negative 1 times negative 1 is positive 1. And then we combine all of our like terms. We have an x, which doesn't combine with anything. I have the 7 plus 1 is 8. And then I have, ooh, interesting. Okay. And then I have minus root x plus 7 and minus root x plus 7 gives me negative 2 root x plus 7. And this one ended up being really nice. I still have a radical, which means I'm going to have to square again, but before I do that, I want to try to isolate the radical. So I'm going to move the x and the 8 over, subtract x, subtract 8. Those cancel, leaving me with negative 2 root x plus 7 equals, x minus x is 0, 2 minus 8 is negative 8. And then before I square, I'm actually going to divide by negative 2. That gives me root x plus 7 equals positive 4. Now we square again. Square, square, x plus 7 is equal to 16. Subtract the 7. 16 minus 7 is 9. And when you solve problems with square roots, you always want to plug it back in to make sure it works. Sometimes, even though the algebra is correct, the problem blows up on you. And I have a feeling that this problem blew up on me. Did I mess up? I'm wondering. Because something scared me. So I plug in 9. Let's see. Root 9 plus 7 minus 1 is equal to the square root of 9 plus 2. And that's not going to be true. 9 plus 7 is 16. Minus 1, square root of 11. That's 4 minus 1 equals square root of 11. And that's not true because 4 minus 1 is 3, which is not equal to square root of 11. And that scares me. Please tell me I didn't mess up. Okay, I found my mistake. Y'all may have been screaming at me earlier. My big mistake here is I said that 2 minus 8 was negative 8. It should be negative 6. So what I'm going to have to do is go back to this point in the problem, although I'm going to go through it kind of quick. So I'm going to erase all of this stuff. All of this stuff is worthless, and I have to start back over by changing that negative 8 to a negative 6. Okay, sorry about all that. So now when I divide by the negative 2, I get square root x plus 7 equals 3. We will square both sides, which gives me x plus 7 equals 9, and x equals 2. And now I'm going to check that. Let's see. So we'll check that by plugging in 2, and we get the square root of 2 plus 7 minus 1 equals the square root of 2 plus 2. And I'm plugging in 2 for my x's right here in the original. Square root of 2 plus 7 is 9. Square root of 9 is 3. Minus 1 equals the square root of 4, which is 2. And that is true. And that's a great reason why you check your answer, because sometimes you get careless. And if I hadn't checked my answer on the first time, I wouldn't have realized I blew up the problem, and I would have gotten that problem wrong. So anyway, that's all of the problems on the next section. And sorry this one took so long, but hey, that's kind of how it is. And we'll do the rest of the review on, yeah, wait, is this it? No, I don't know what's going on.